Hello, my name is Mateo, and today we're going to be covering Chapter 15, Problem 25. And the problem is right here from the textbook. It was actually the same question, well, modified, but this was the same question on our Chapter 4 test. Yeah, so let's get into it. So in this question, the 18-tooth pinion in the figure is driven by 800 RPM by a motor that delivers 20 pounds per inch of torque. The gears provide a double reduction in speed with the output taken from the 36-tooth gear. Both the 6-pitch and 9-pitch gears have a 25-degree pressure angle. So then neglecting the small friction loss in the gears and the bearings, determine the radial loss applied by the counter shaft, the bearing of A and shaft, and yeah. So for the assignment, we're gonna specifically look for the gear dimensions, force components, and then we're going to solve the full body diagrams. So we can see here in the picture that was given, so if this gear down here is rotating clockwise, that means that the bigger gear, so gear A, is going to be driven this way, and then it's on a shaft, so that means that this one is probably going to be rotating the same way, which will be turning this gear this way. So and here is the full body diagram representing that. So we're specifically looking at A and B in this problem. So here we have the tangential force and then the radial force for gear A, and then we have the same thing here and here for B. And then we also have their vertical, and that should be horizontal forces. So here, 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 and here for gear A and B. So we need to find all those forces, so let's do that. But first, to get there, we have to find the dimensions of the gears. So with our given, I wrote it down here, all this. That was from the problem. Now it's just nice and organized for us to start. So in pink, we have our equations right here, and we're going to find the diameter of the pinion gear. So to do that, we're going to take the number of teeth, which was 24, and then we're going to divide that by the pitch, which was 6, and that's going to give us 4 inches. And we're looking at this gear specifically. So now that we've done that, we are able to move on to the next part, which is right here. So to find the tangential force, we can use this equation. So we're going to divide the torque by the radius. So that's going to be 20 divided by 1, which is just 20. And from there, we can find the radial force using this equation. So 20 times tan, and then the pressure angle, which is 25. This is all stuff that we were given from the problem, except for we used what we just found here. And then from here, we get these two forces. So that's pretty much solved for gear A. We found this force and this force. So now we got to move on to gear B. And we're pretty much just going to do the same thing, but using a different equation for the first one, because we don't know what the diameter is. So here's how we can find it out using this equation, and we can find the tangential force at the same time, which turns out to be 35.55. And then using that, we take that and we put it into the same equation we used above to find the radial force, and it is 16.58. And then you can see them all here on the full body diagram. And I I did it this way to show you guys because it was gonna take too long to solve the whole problem, so I figured this was a better way to just explain it. And then to find uh, these four forces, you have to find the moment, and to be able to do that, we can then get solve these here, and that's how we can find the resultant forces as well, which are here. So that's about everything. I hope this video was helpful, and yeah, that's about it. Thanks for watching.